Wow, a little longer than I expected it to be. Hi, everyone, and welcome to today's session. My name is Rex Wang, and I'm going to take you through a general session today entitled Roadmap to Enterprise Cloud Computing. Thank you to Mike and Mohammed for an excellent keynote address today. So with that, let me start. This presentation is about enterprises and how enterprises should get to cloud computing. What does the journey look like? What does the roadmap look like, etc.? So data centers, right? Many of you have data centers, know about data centers, and we see data centers on an evolution today. Today, many data centers still exist in these silos where applications run on dedicated stacks of middleware database, servers, OSs, storage, and networking. Data centers are moving, however, to a more consolidated model to save money. They're moving to a shared model where instead of running on dedicated servers, we're running on shared infrastructure and therefore achieving economies and able to balance that workload. Previously, in the siloed world, everything was sized for worst-case workloads, so inherently there was overcapacity in the system, right? You're designing intentionally for that peak workload. But in a consolidated world, you can save some of that by smoothing that workload. From there, data centers can move to an optimized environment where the layers are standardized, for example, and we're able to achieve greater economies from limiting the heterogeneity that is inherent and being more efficient in terms of management. And eventually, the idea is to move these data centers towards the cloud. I think people sort of generally see this evolution. At the same time, technology vendors are trying to service the needs of enterprises who are moving through this transformation. Originally, there are many vendors out there producing best-of-breed components at various levels, and that's a fine strategy for siloed environments and for consolidated environments. But I think as the world moves forward, the technology stack also needs to evolve. So we're talking about going from best-of-breed components, individual components, to optimized systems, and eventually to these engineered systems that Mohammed already described. So we see that vendors like Oracle and others need to evolve their products to meet the needs of the data center. Some of the trends that are happening in data centers today, I think many of you are familiar with this. There's a general trend moving from physical environments to virtual environments, from dedicated environments to shared environments or pooled resources, one of the key characteristics of cloud. From heterogeneous, mixed, diverse environments, which are complicated and expensive, to more standardized environments of standard middleware database servers and storage, for example. Where management used to be highly manual to an environment where it's highly automated. How else can you hope to manage the diverse set of virtual resources in your environment? Shifting from an IT-managed world where IT staff are meeting the service requests and doing things, to a self-service model where end users can do certain things for themselves subject to certain policies. And then finally, moving from a world where components are assembled by the customer out of piece parts on the floor of their data center, perhaps with an systems integrator, and it takes perhaps several months to get that done, to a world where engineered systems are pre-assembled at the factory and delivered in a fully optimized and functional manner to the customer. Some of the trends that are happening today. So we see a general evolution towards cloud computing as well that kind of mirrors some of the stuff I just mentioned. This picture tries to show the private cloud leg of this, where, again, many organizations today are moving from this physical, siloed environment to a highly virtualized and shared environment. Probably 90% of the customers that I talk to today are already doing this in some form. So it's a very popular strategy to standardize and consolidate. However, this 90% of our customers are probably doing it in only about 20% of their data center. So they're just getting started. They have not yet fully virtualized everything, and potentially not everything will become fully virtualized, but there's still certainly plenty more to go. From here, we believe that many enterprises will further evolve by adding some of these cloud characteristics that the NIST organization describes, for example, self-service, provisioning, self-service monitoring, self-service management, policy-based resource management, which is another way of saying automatic scaling based on rules, based on service level agreements, for example. Chargeback, right? Now that applications run on shared infrastructure, it's more important to measure how much of that shared infrastructure each application or each user is consuming. Typically, you want to measure that, and you want to use that for either billing information or chargeback information, depending on whether you're talking about public or private cloud. And then capacity planning. That's very different in the new world as well. In the old world, IT would buy capacity, would buy hardware after projects were approved, and they would size those purchases for expected peak loads or future growth. But in a cloud world, IT now needs to buy pools of IT resources in the hopes that consumers, departments, lines of business, whoever's using the services will come and use that shared service. So capacity planning and purchasing is quite different in the cloud world as well. At the same time as these private clouds have been evolving, public clouds are also evolving. Many years ago and to this day, we have a number of different types of entities out there: ISPs, ASPs, MSPs, telco communication service providers, and traditional ISVs, right? All these different entities are evolving as well, and they're evolving towards these cloud entities in the SaaS, PaaS, or infrastructure layer. Today, there are hundreds, if not thousands, of these public cloud entities. They're highly specialized. They're fairly fragmented. They're isolated. They don't talk to each other. It's very difficult to move workloads around from one to the other. But there are many of them that exist today. And ultimately, we see this evolution towards this end state of, let's call it a hybrid cloud, where applications can run across both public and private, where they're interoperable and portable, right? So this requires, interestingly, it requires standards for interoperability, right? These standards are not fully in place. They're being developed right now. Oracle is actively participating in that standards work. In fact, I think you'll see a press release from us shortly during this show about some of the contributions we've made to the standards development process here. We want to enable interoperability. We want to enable portability of workloads from one cloud to another, from one public cloud to another public cloud, from your private cloud to a public cloud, etc. That portability and fungibility needs to be built in, and it's based on, number one, standards, and number two, technology implementation of those standards. So here's some of the evolution that's happening, and we believe that most enterprises are on this journey. We don't think that companies will move whole hog from one phase to another. In fact, most companies today are deciding, I've got, let's say, 1,000 applications. I'm a large enterprise. Of those 1,000 applications, how many of them are I just going to leave alone? They run in dedicated hardware today, and everything's fine, everything's dandy. Maybe I just leave it alone. So I leave a certain set of applications alone in their silos. Other applications I might decide to move to a virtualized and consolidated grid environment, as the second phase of this picture shows. That's a consolidation thing, and many companies are doing that today. Other applications, I might move to a self-service private cloud, and yet the fourth bucket, I might move some applications to the public cloud to take advantage of that elastic, pay-as-you-go sort of resource. So we think that most enterprises are making sort of application portfolio decisions today on what to do with their current applications and new applications that are coming down the road. I wanted to, so one more slide. So, I think there's this basic notion of public and private clouds. Most companies have this choice that they're making between public and private clouds. It does amount to a trade-off, trading off, low upfront costs and very fast getting started, the ability to get started very quickly, trading off that low barrier to entry against, let's say, long-term costs, right? The break-even period for IT projects might be 2, 3, 4 years, but beyond that, it might be cheaper to own your own infrastructure versus renting it. Who knows? The other trade-off people make is whether or not I'm going to outsource to a public cloud, because that's essentially what it is, to do I want to retain control for security reasons or compliance reasons or regulatory issues? And then finally, OpEx versus CapEx. Clearly, public clouds are paid for by operating expenses. typically out of the line of business, out of the department, not from IT. It's a way of bypassing the IT budget, right? And private clouds tend to be a combination of CapEx and OpEx that is the IT budget itself. So fundamentally, Oracle we believe that enterprises will adopt some mix. They'll make their own decisions around what types of clouds to adopt for what applications. I actually wanted to run a little interactive real-time poll today, if that's possible. This is a poll. If any of you have cell phones or computers that are on and connected to the web, you can vote right now, and I urge you to do that. The question that we want to ask you is, do you provide or use an internal or private cloud? You can either text your response, so you can text that keyword, let's say production, limited, pilot, planning. Text those keywords to short code 22333. Alternatively, you can tweet your response with that keyword to that Twitter handle @poll, or you can open up a browser right now and also submit the keyword that way. Well, I'll give you some time to do that because I think the results of this might be interesting. I think we have 2 responses. There must be more people connected to the web in this room than that. It's a slow net. Use your cell phone. Text messaging rates do apply, I have to say that. But we're not making any money off of this. Yeah, I think this is some interesting responses. Okay, we're getting there. So interesting. There's quite a large group of people, initially at least, that have a private cloud in production today, or limited use, or in pilot. And there do seem to be some of you who are in early planning or under consideration stages as well. Well, I'm not going to turn off the poll. You guys can keep voting if you'd like, but I'll come back to this in a second. I think this is interesting, and I think Mohammed showed a pie chart earlier that had similar results. It turns out that last month we ran a survey with the IOUG, that's the Independent Oracle Users Group. We surveyed about 300 customers. We asked them about 30 questions, and this was one of the questions we asked them. These are the results that came back from that survey. You can see that in a group that, admittedly, the IOG is a biased sample because these are typically Oracle customers, but roughly 30% of our customers came back and said, we have a private cloud today. Let's try this again. Let's try another survey, if you guys still have your cell phones out and web browsers open. The question this time is, does your company use public clouds? And the keywords are public, no public, and considering. Again, you can text them to that short code, tweet it, or submit it into that web page. Interesting. Interesting. Okay, that's actually a very significant percentage of you are actually using public clouds today of some form. It's not clear from this survey. We should probably be more precise. Are you using, a service like Amazon EC2 or S3, which is a platform for development? Or are you using, perhaps a SaaS application from, a vendor, an application that's ready to go for end users? We didn't ask that question here, but it would be interesting to break down that 65%. So one thing that I'll point out is that when we asked the IOUG audience this same question, we got a slightly different result. We got this result. So this result says only 14% use public clouds, while 55 do not use public clouds, and the rest are ambiguous. So I don't know who to believe. Maybe we have a biased audience here. I mean, if you're going to come to Cloud Expo, presumably you have some connection to the cloud world. But I thought that these 2 results were interesting. In our survey, we found that basically roughly double the number of respondents had private clouds versus public clouds. This is a chart that Mohammed already showed. We also asked him, if you have a private cloud, what type of private cloud you have? And the answer came back, quite a variety, but a slightly more preference for the platform layer, with things like application server as a service and database as a service and identity as a service compared to the lower level infrastructure offerings of compute and storage. And I put software dev and test in there as well, just because I believe that's primarily infrastructure level. So some interesting findings, and if you get interested in the full results of this survey, it is available, and come to me afterwards, and I'm happy to share the full survey results with you. Another question we asked was, so what kind of application are you running in your private cloud? And you can see it's quite a mix. It's quite a mix of back office applications, financial accounting, HR, customer service, procurement, etc. I didn't see a clear pattern here other than, it seems that many, many different kinds of back office applications are being used. Fewer number of, front office applications. These are the kinds of apps that probably don't differentiate the business. They're not strategic. They don't give the business strategic or compelling competitive advantage. But for back office things that don't give the business competitive advantage, there was certainly a lot of willingness to put those into private clouds. So let me switch gears and talk a little about something else. So, we believe that most enterprises are on this evolutionary path or journey towards cloud computing. And we think that one of the first steps that many companies are embarking on right now is this one, is the idea of standardizing and consolidating. Why? Because I'm trying to save some money, essentially. Pretty basic and straightforward. I want to point out, though, that this type of consolidation can happen at different levels. So some vendors will say, all you need to do is consolidate using virtual machines, right? Take 100 apps running on 100 different machines and use virtualization technology to shrink that down to some smaller number. And I want to point out that, that's one way to do it. It's not the only way to do it. There are actually other technologies that allow you to share as well. For example, clustering is a technology that is complementary to server virtualization, right? Server virtualization makes one piece of hardware look like many. Clustering is kind of the inverse. It makes many pieces of hardware look like one, right? And some combination of these two things is important in order for you to achieve the proper levels of consolidation. Both of which are key, both of which deliver on, two of the key concepts of cloud, which are sharing and elastic scalability. You need both of these. You need both server virtualization that is a hypervisor, right, as well as clustering technology. So the other thing to think about is there's more than one kind of server virtualization, right? Some people will have you believe that, hey, it's all about an x86 hypervisor because everything is that world. Well, that may be true for many cases, but it's not the only form of server virtualization out there. In fact, Oracle offers a bunch of other things too. There's an alternative hypervisor technology for Spark chips, for example. We call that Oracle VM for Spark. It's also called logical domains, for those of you familiar with that. There's a Solaris technology known as containers or zones. And the difference is each zone can run different versions of Solaris, but it's all running on a single version of the Solaris OS, which makes it much more efficient. You can get many more virtual machines or zones in that environment than you can with hypervisor technology. And then over at the far left of the scale, at the M series, these are the high-end hardware boxes from Sun, we offer something called dynamic domains, which is complete electrical isolation of one system from the one adjacent to it. So there are many ways to skin the cat here, and these are some of the different forms of server virtualization that are out there. I'll also point out that you can do consolidation at other levels besides the virtual machine. You can do consolidation at the database level, right? And there's actually three primary alternatives you have that you can use. It's the first one in the upper left is called shared server, and that does use virtualization technology. So that splits up each hardware server into different virtual machines and runs an OS and a database on top of it, on top of each one of those. Another model is called shared cluster in the lower middle of this page. And that utilizes technology that Oracle has called RAC, Real Application Clusters, where you can have multiple databases running on a cluster of machines. The clustering is accomplished using RAC. There's no server virtualization in this architecture, yet it achieves this concept of the ability to mix different applications or workloads onto a cluster of machines. Again, that thing called shared cluster does not use virtualization technology, yet it achieves the same goal of consolidation and isolation. The third model is called shared database, where we actually have a single database running on top of a cluster of machines, and you utilize the traditional database, schema and user access controls to do the isolation. So you can achieve mixed workload consolidation using that approach as well. Again, an approach that does not necessarily use virtualization. So I'm trying to break the association that many of you might have in your heads that consolidation is about virtualization. And yes, in some cases it is, but not in all cases. And you might want to think about the different methods that are available to you. By the way, the same thing is available in the middle tier. This is an example using WebLogic, and this is an example combining both virtualization as well as WebLogic clusters and WebLogic domains as a way to achieve, again, multiple applications running on shared infrastructure with virtualization as well as clustering together combined. So there are many different ways to skin the cat here in this area that we call consolidation. So bringing you back to this sort of notion of evolution and enterprises evolving, the roadmap to cloud, some people will take the first step of consolidating onto shared middleware, shared database, or shared servers. The next logical step might be to evolve to a self-service private cloud. So what is a self-service private cloud? What would that look like? I want to use this picture of this is an oversimplified picture of a private cloud lifecycle to illustrate to you what would a private cloud actually look like. Well, it looks something like this. The first thing that has to happen is step one there. IT has to build the private cloud for end users. So it might build it at the platform layer, or it might build it at the infrastructure layer. Those are the two boxes shown in red. Step number two, IT would build a set of shared components. They're shown in gray in this picture because these are not products. Those are services that are specific to the enterprise, right? These are specific standard and reusable components that are specific to the enterprise. The third thing that IT does is build the self-service application or interface. That's the gray box on the right. And this application is going to contain the right identity policies and procedures and so forth and workflow to make sure that end users have the appropriate access to the right resources, right? That's all step one, and I've dramatically oversimplified that. But once you've got that cloud built, the second step is step number two. You have to build apps on top of that cloud, right? And step number two is developers who might live in lines of business or departments or subsidiaries, what have you. These developers come in through that self-service portal. They discover what are the available, standardized, and reusable building blocks that are already made available. That is those little gray boxes on the lower left. And then they assemble the application out of these reusable building blocks as opposed to reinventing the wheel and doing it from scratch. Then they're able to deploy that application through the self-service portal without IT involvement. So that's the second step, and a pretty important one there. So there's actually, when you're thinking about the cloud lifecycle, there's kind of two phases of the build. Number one, you build the cloud, and number two, you build the apps on top of the cloud, right? Then you move into the runtime. That's what step number three is. In the runtime world, of course, your users are using that application. While they're being used, the application owner in step number four is able to monitor the application through self-service, able to adjust capacity, scale up, scale down, etc., able to watch over how much IT resource is being consumed and how much is my department being charged for that resource. That's the chargeback piece. And I left off a bunch of steps here, patching and decommissioning and whatnot, but I've tried to oversimplify this so you get an idea of, what would a private cloud look like within an enterprise. So what does Oracle have to offer to help enterprises build private clouds? Well, we have solutions that fall into two big buckets, the platform bucket and the infrastructure bucket. Both of these buckets have the following characteristics. In both the platform and infrastructure tiers, we offer components that are shared, that are elastically scalable, and that are highly available. Right? So in the platform layer, that includes middleware and database. In the infrastructure layer, it includes servers, storage, and networking. Right? We offer extreme performance by way of these engineered systems that Mohammed mentioned that offer very high, very ease to deploy, right? Because it's easy to deploy. It's also very efficient in allowing you to consolidate a large number of applications onto a relatively small amount of hardware, and therefore has a total lower cost of ownership as well. But our offerings really are in both the platform layer and the infrastructure layer. We believe that management of the cloud is critical as well. That's what that column on the right of this page. We offer a very complete end-to-end applications to disk, complete lifecycle management of the cloud. We think that it's important that you manage more than just the virtual machine, right? If you just manage a virtual machine, for example, you have no idea what's running inside of that virtual machine. It's really impossible to manage, end user SLAs or diagnose issues in that stack. You really need a system that is able to manage the entire application stack from the end user experience through the application middleware, database, servers, and storage and networking. So we think that cloud management is a very important ingredient to this solution as well. Breaking this down, we have a number of offerings. I'm not going to walk through all of them, but it looks something like this. Exadata looks something like that, and Exalogic looks something like that. So both of these engineered systems overlay onto the solutions because Exadata, as you probably realize, provides not only a database, but also operating systems, smart storage, and InfiniBand networking all in one box. So the height of that box correlates to what Exadata is providing you. We think that these two engineered systems are the ideal building blocks and ideal foundation for clouds, both PaaS clouds as well as infrastructure clouds. They offer unmatched performance, simplified deployment, and lower total cost of ownership. In addition to that, though, we also have other offerings. Clearly, when you think about the evolution of hardware from sort of basics, server storage and networking, once we combine hardware with software, we're able to offer these optimized reference configurations, as well as sort of the ultimate in that, which is these engineered systems. One of our other offerings that's not Exadata nor Exalogic is this one. This combines Sun Blade servers, which are very dense and highly performant, based on x86 or Spark, but this one happens to be x86. We combine that with Oracle VM virtualization technology, with operating systems Linux and Solaris, and we combine it with storage. And now suddenly we are able to offer a building block for infrastructure as a service offerings that combine both compute and storage, for example. So look for this on the show floor today. When you go out to the exhibit area, you'll see one of these Oracle VM Blade clusters out there, and you'll see a demo for that if you're interested.
Thank you. I just want to show you an example application that we've been working on for the last year. This is an application. It's an example of a self-service portal. It's really geared towards our larger customers who, for the most part, have existing provisioning and deployment solutions. And when they see the Oracle solution around Assembly Builder, they like it. But a lot of them want they want something to plug into into their existing solution. So we created this example application. We've open sourced it. And so far we have a lot of interest. It's an ongoing effort. So we're continuing to develop this. It focuses right now primarily on the role of a tenant. So in this example, I'm going to sign into this desktop application as a tenant. And basically what this is showing me, I signed in here as Tom Johnson. Now, Tom Johnson has deployed 2 different platforms, and within one of the platforms he has 2 different assembly instances. What this does is it lets a user, a tenant, set up, let's one of our clients set up a private cloud where they can import assemblies from Assembly Builder, present them as a list of catalog, a palette of options to a user, and a user can come in and create instances of those assemblies and then manage them. They can control their own environment. So they could have a CRM application, for example, which is shown here in the catalog as an assembly. A user can come in, search it out through some metadata tag, and create one. They can use it for however long they want, and they can stop it and delete it when they're finished with it. So this is their desktop where they can see on the left the different platforms they can create it, and there's kind of a dashboard view in the middle where it's showing some of the additional usage information as far as how much memory, uptime, and some rudimentary chargeback information. So a tenant can come in, stop or delete their platforms. They can go into a specific platform that may have more than one instance of an assembly and individually control an instance of an assembly. You may be a tester and you've got a number of different point releases of a certain product where you can create one platform for the product, and then you can create a number of different instances that represent all the different point releases. You can individually manage the point releases or manage the entire release as a whole. Some of the other things you can do as a tenant, you have the ability to not only deploy your assemblies, but you can also scale them. Because it does track CPU utilization, if you've got some assemblies that are underperforming, you have the ability to manually scale them out. So you can come in, pick one of the different appliances that's part of an assembly, scale it up, scale it down, because maybe there's a chargeback policy in effect and you don't want to have something running if you're not using it. Here's an example where a tenant is going to go in. I just clicked on Platform Templates, and it's showing me a list of all the different templates that have been imported from Assembly Builder. So these templates represent entire applications. It's everything about the application, including all the configuration information. So a tenant can search by a variety of different tags. So I'm going to type in WLS in this case, because I'm looking for something that has WebLogic in it. It's giving me a list of all the different assemblies that have that type of component. I could have put in the name. You notice here this came from a Sun domain, or I can put in Avitech. In other words, any type of metadata related to that assembly, you can use it for search criteria. Once the tenant finds the assembly they want, they can click Deploy, and then they have the ability to deploy that assembly and either use what we call an existing deployment plan, or they can create a deployment plan on the fly. So in other words, you could have one golden image, and you can have multiple ways that you want to deploy it, different options as far as how much memory, CPU, IP addresses, port numbers, whatever, to control how you deploy it. So in this case, I'm going to pick a deployment plan. I'm going to say use an existing deployment plan for this sandbox. And it'll bring up all the different options. So it's loading them, and it shows you by appliance. So if there were multiple appliances, like a database, a web server, an app server cluster, would list them all separately. I'm going to pick the sandbox, which is a WLS type of component, and you have the ability here as a tenant at runtime to change these. You don't have to do this. You can just say use it as is. But maybe if I'm a developer, I may want to bump up the number of CPUs, because I need additional resources beyond just one CPU. I may want to bump up the memory from the standard template of 1 gig to 2 gig. So it lets the tenant change the parameters that are within reason, things that they would typically do at runtime. So once you pick your deployment plan, specify any overrides, then the system will go and it'll make sure that it has the physical resources to deploy that, as well as you have the quota and the rights to deploy it. So this really doesn't deal with infrastructure. To Rex's point earlier, it assumes the infrastructure setup. It's really simple for a tenant to come in because they're just deploying it to a pool of resources that have been pre-configured for them. So in this case, it says that there is sufficient disk and memory. This person doesn't have a quota, so it really, in their case, only really cares about whether there's sufficient system resources. If there is, you can go to the last step where you have the ability to specify when you want this to be deployed. So you can pick a specific date and time. You also can bundle more than one assembly instance into something called a platform. A platform is just a grouping of your instances. It's just a way of controlling either cost, usage, as well as starting and stopping. So if you want to start things at a group level, you can. If you want to stop things at a specific assembly instance level, you can do it that way. So in this case, I'm going to, for this new instance of an assembly, I'm just going to create a platform. So it's going to be a one-to-one relationship. So you put in the name, you can put in a description. We also have some things here, because this is really meant for the do-it-yourself customers. Customers who are using this are hooking this portal into their self-service portals. Or they're basically extending this and they're using it at a service level, and they're hooking it into their existing deployment engines. This example application uses Oracle APIs below the surface, but it is an example application. It's meant to show customers how to do self-service. So we do have extensions for things like pre- and post-deployment. You can see them on the right there. So in other words, if you want to, before you deploy, hook in one of your existing scripts, and after you deploy, hook in one of your existing scripts to do something like a load database data, as a byproduct of the deployment, you can do that. So once you're finished, you say, schedule this request. You'll see it as a waiting request. The users have windows here that show things like their alert messages as well as their waiting requests. So we can see that it's waiting. The users can basically watch the process as it executes. It goes through a multi-step. In this case, it just kicked off step 1 of 4. While that's going on, I also just clicked on metrics. This does keep, as part of the main tenets of a private cloud, being able to monitor usage and calculate chargebacks is one of the things that customers find important. So we do have the ability, when you deploy these instances of assemblies, you can track things like how much memory you're using, how much disk, CPU utilization, and you can do it on multiple tiers. So you can do it at a platform level. If if you've got multiple instances within that platform, you can look at each assembly instance, in other words, each build or each test instance that you created if you're a tester. And so you can drill in and look at the usage and the chargeback information. And because this is a work in process, we're going to have reports and things that this will generate. But for the time being, this is really just focused on a tenant. How to put into the hands of a tenant the ability to utilize these assemblies and deploy them at will, and then manage them on their own, scale them, and get basic charge information. So that's it. That was kind of quick, but hopefully you got the main point.
Yeah, thank you, Chris.
Thank you.
Thank you, Chris. If any of you want to see that demo, of course, we'll be showing it in the demo pod outside later today. Just let me quickly wrap this up, if I might. And so I just have a couple more messages for you. That was Chris showing, an example of a platform as a service being accessed through a self-service model, the ability to deploy these multi-tier applications that are greater than just a single virtual machine through the self-service portal, and to scale it and monitor it, et cetera. So I just wanted to close with the following notions. Oracle believes that customers are going to do both. They're going to do private clouds, they're going to do public clouds. They're trying to figure out what I'm going to just simply consolidate, what I'm going to put in a self-service mode, what am I going to put in a public cloud. And so our goal is to really offer customers choice. And there's a few parts of our strategy. We have this part of our business called Oracle On Demand, which is the actual part of our business that actually offers cloud services. This is part of Oracle that is a cloud service provider. we offer a wide range of Oracle applications, both horizontal as well as industry. In a cloud model. We run our own data centers, and customers come in and consume these as services. The second part of our strategy relates to applications. Obviously, Oracle offers a whole bunch of different apps, and the interesting thing about our apps is they are available in a private shared services model that is not in silos but running on a shared platform. That's Oracle Fusion Middleware 11g. And they can also be deployed in a public SaaS model as well. So we recently announced our Fusion applications, and Fusion is a very important strategy for us to try to enable both public as well as private cloud computing. On the technology side, which is for us anything that's not an application, there's two pieces of our strategy. One is we're going to allow customers to run Oracle technology in third-party public clouds. Mike Peach showed you a couple of examples of that, where customers can run Oracle in their own data center, or they can run it on Amazon, or on SYS, or on other service providers as well. So we're enabling customers to move their workloads around between internal environments and these public clouds. Another aspect of that is there are some public clouds that we're actually powering their service. So, for example, there are a lot of SaaS ISVs that are out there, such as Salesforce, for example. And those SaaS ISVs, their services are actually powered by Oracle technology, by Oracle Database, by Oracle WebLogic, for example. So our strategy there is to power third-party public clouds and their SaaS offerings. And then last but not least, we do think that a large chunk of customers, particularly on the enterprise scale, will prefer private clouds, at least for certain applications. And so our offerings there really are the Oracle Private PaaS and the Oracle Private Infrastructure as a Service that I thought I'd share with you. This sort of four-legged stool here is the Oracle strategy. We're trying to offer customers the choice to do whatever they need to do. Last thought I want to leave you with is, so how do you get started on this roadmap to cloud? If you're an enterprise, it may seem daunting. And I do think that there are some steps that you should consider. When you're doing your basic cloud planning, what is your strategy? What applications go where? What am I going to standardize on? What am I going to consolidate? What am I going to outsource? Some of the key application portfolio rationalization types of decisions that you need to have. Also, what is the business justification to move to cloud computing? A lot of consultancies can offer some help here in creating, your business case for moving to cloud. And then where are you in the maturity of your organization and readiness to move towards cloud computing? They can help you assess where your organization is in the maturity model or the maturity spectrum. Some of the key considerations here are not technology related at all. What are the economics to do this? What is the funding model? How am I going to pay for this project? How am I going to do capacity planning? What are the metrics that I'm going to use to charge back? Is my organization even ready for chargeback? Right? Or am I just going to stick with a traditional allocation model? How does my organization, roles and responsibilities, entitlements and authorization levels, how does that change when I move to a self-service private cloud? What is the governance model? What are the policies and processes? You can see here that there's a range of things you need to consider. And I think that a lot of companies are well down the road, and other companies do need some help. We offer something called Insight Workshops, which are free resources that Oracle offers to customers that are sort of wrestling with some of these planning issues. So if you're interested in sort of getting some help, come see us, and we'll try to hook you up with the part of our business that conducts these insights. So that's really all I had today, and I think with that I'm going to close and say thank you very much for your attention.
Thank you, Rex. Thank you, Chris, Mike. Thank you to Mohammed, who's already on his airplane on the way to his next gig in Chicago, which is